Welcome to another small disc golf video. This is the third in a series about designing a new disc. This episode is all about slicing in the PrusaSlicer. The first thing to do is to export it as a step file. A step file includes the design history down here, which is important. It means that if somebody else imports this into their drawing program, they would be able to adjust the sketch, like drag the spline points around to make the disc slightly different for their needs. So to do that, you use the File menu, and you choose Export, and then you choose a different format. You choose the step file. You could choose STL. An STL file is just triangles. It doesn't have design history. It's very hard to manipulate. You can't really do anything with it. If you want to prevent people from doing things easily with it, then STL would be your format. But I always share with step. And I'm going to export this file. And I'm going to call this practice 2. Export. And it takes it for just a moment, and now it's done. Now I'm going to use the PrusaSlicer to slice the model and get it ready for printing on my printer. And to do that, I've opened up PrusaSlicer 2.6 Alpha 5, and I am going to drag in the step file that I created. You could also use the import menu. And I'm going to change its orientation. I'm going to flip it up. So let's try 90 degrees. That's good. And I happen to like printing it so that I can see the inside edge. So I think that's minus 90. Nope, it wasn't. It would have been 90. So let's change it 180 more. This is where I like to print it. And I like to put it out in front because this is where my webcam can see it. The slicer automatically guarantees that the bottom is touching. So this is pretty good. So now let's look at the options that we think we're going to need. So let's look at print settings. So I like to print these with lots of perimeters. I don't really want any infill at all. If it's too thin for 6 layers, that's fine. It will only use as many layers as it actually needs. And I also want to avoid crossing perimeters. That's pretty important. And that's all good. And then for infill, it's not going to need any infill, so I'm going to give it 0%. It probably doesn't matter at all. And then for skirt and brim, I am not a fan of the skirt over one layer. I think it serves a purpose at one layer as sort of a secondary purge strip, but I think more than that is a waste of PLA. And I am going to put on a brim. It's not a waste of PLA. It's an important part of making sure that it doesn't break loose while it is printing. I also do not want any separation from the brim and the object, because the object is the print base that it is next to, and I want as solid of a connection as possible. So I want 0 separation there. Normally you want the brim to come off your object because the thing that it's next to you care about. And then I suspect we're going to need supports with this. We'll get back to that. Let's look at filament settings. And I like to print the first layer at 210. And I like to print the other layers at 190. And I can hear you screaming at me. But first of all, the PLA that I work with, 190 is at the bottom of its recommended range. And so they probably would not include that number if it didn't work well enough. It does work well enough, and what it does is it helps reduce stringing. This is about the lowest temperature that you can go and still have a strong print, and it minimizes the amount of stringing. The first layer does need to be more, needs to be hotter because we want it to have more adhesion, and it does work better. I go with 60 on the bed temperature because I don't really have any reason not to. And then over in print settings, on extruder 1, this is very important. No lift Z. So that means that the head does not bump. And there are two really important reasons for this. One is that it reduces stringing a lot. It's almost ironing every layer, because if it has to move somewhere, it may iron on the way. It's not going to cross the perimeters, and so it either has to not be in the perimeter or it has to follow the perimeter. The other reason is that if you have a Z-rider with, say, a Kodama on it, then it won't be a bumpy ride, and that's something too. So back to print settings and support material. Let's look at what we've got here. Let's slice it and see how it looks. And I'm going to bring it up into a little bit better view here so we can sort of see it from the top. And oh, thank you for your opinion. And you can see how even where it's thick at the top right here, I'll bring it closer, those are still the perimeter layers. As you go down, it's just perimeters all the way. 3 layers thick. And when we get to the very bottom, at the print base, let's see how that disappears into the print base. So that's the first layer that's above the print base that's part of the disk. And then there's the top layer of the print base. And there's the next layer of the print base. And there's the next layer of the print base. And that actually, that third layer of the print base is the bottom layer. And so there's 3 layers of print base, and I think that's ideal. That's a 0.5, I believe, is what I created it as. If you need a thicker one, you can make it 0.66, and you'll end up with like 4 layers, I think. And you could make it 0.4, and you end up with 2 layers. And those can all work depending on your printer and other factors. But let's see how this looks. In general, my concern with this is that there's a lot of overhang. Let's go back to this view. There's a lot of overhang under here. I'm flipping this around so we can look underneath the leading edge. There we go. Now you're looking into the leading edge. That's going to have to print. Here, I can put it in the correct orientation. But that's going to have to print. And that could be very hard. That might be a very long bridge. And I can show you some examples with photos where that kind of thing doesn't work. This is the problem I ran into with the Falcon, was that this edge was very hard to print. And not only that, this edge under here was also very hard to print. So what I did was I used organic supports, and I had to tell it exactly where I wanted those supports, and I'll spare you the learning process. But I use the paint-on supports, and I go with a circle that is a little smaller, like maybe that. You can see the size of the circle. Let's bring it in closer so that it's easier to work on. But basically, the entire underside here, a narrow strip, needs to have circles. The supports go all around the bottom edge on both sides and around the top inside edge, but not the top outer edge. You don't want them going over the top. You saw me delete some there. You don't want them going over the top because it'll actually build supports up over the top, and that makes it hard to take off. All those have to be removed, and there's probably a better way to draw them without getting those. I'm also going to fill in these little gaps in here. This down here is telling us that, warning, an object has custom support enforcers, which will not be used because supports are disabled. And it's absolutely right. Print settings, support material, generate support material. But don't auto-generate supports. We have told it where we want the supports. And we would like organic supports. And I have learned that you'll have an easier time getting it off if you increase this to maybe 75. I've seen people on the web use it as 100%. I'm going to try 80%. 75 works, I know, but always ready to learn something new here. The very worst that happens is that it's too far from the thing that it is supporting and it sags, but we're talking about the difference between, less than 1/10 of a millimeter, I think. The problem with it being too close is that it gets hard enough to remove that it's a bummer, and you might have to sand off the remnants. So now that we've got that, let's go back to the plater, and let's go back to the slicer here, and let's slice it, and let's see what it looks like. And it takes longer to slice it to generate all that support material. We're going to have a look and see if it looks reasonable. Whoa, that is a lot of support material. So these things on the side, that's what I would expect. These things are supporting the front edge. That's a lot. We actually don't need support here and there. I'm going to get rid of it. So I'm going to go back to here, and I'm just going to make this much bigger. See how big that is? I make it even bigger. And if you hold down the Shift key, it's an eraser. So let's get rid of that, and let's get rid of that. There we go. How's that? Yeah, I got rid of maybe a little too much. Not really. I think that's fine, and I think I'll even get rid of this here too. There we go. Let's try that. Let's slice that. It's going to generate new supports. Okay, nice. Okay, it's outside the toolpath. That's fine. All that means is we have to go back here and drag it. Oops. Sorry. Let's go back and move things around mode. And let's move it a little further away from the edge. Okay. Let's slice that again. Because the organic supports were next to the disk over here, and they were actually off the print. So this is pretty cool. If you notice, this organic support starts outside the disk and then goes inward to support the underside. It's really beautiful. I mean, I like to save these things. I think something could be done with it. Here's an overhang. You could consider putting it there. I bet it's not going to matter. I think that it can handle that much of an overhang. But if we wanted to, we certainly could put an organic support there. Let's try it without. So I'm going to, here, let's have a look at how it all looks. This is how it breaks down. Let's bring it over here like this so we can see it from the top. And here it is from the top, building down. You can see how the organic supports are just circles on top of circles, and they work their way down. The disk works its way down. The outer supports support the underside edge. And there we have it. Super cool. It's okay with putting its organic supports on the brim, but not on our print base. And that's, I don't think it matters. Makes them a little bit longer. That's about it. You can see over here that we're actually using 27.8% of this print is support material, and that's a bummer. That's a lot of support material. On my other discs where I don't have to generate supports, there's like 5%, and that's just the print base and the brim. Anyway, let's export the G code, and I'm going to save that to here. And then I'm also going to hit save to save my file, and we'll call it practice2 3mf, and that puts it in the same directory. So I printed this new disk, and it printed fine. I am tempted to print it without the organic supports. I think that they're wider than they need to be, but they do work. Look at the top of this disk. You can see the layer lines. It's pretty good. I mean, it's very well supported. And I did take the supports off, and they came off very easily, all in one piece. PrusaSlicer is an amazingly configurable tool. And that's a twin-edged sword because there are so many choices. How do you know which ones are going to improve the print, which ones will cause problems? Different filaments might need different print settings. I think it just takes experience and practice and getting to know your printer. And printing the same kind of object in different filaments or on different printers helps you understand the difference between those filaments and printers as well. Thanks for watching this smalldiscgolf.org video.